Hi there, hope you are doing fine. This is Mr. Philip Koma, the excellent biology tutor. This is a weekend past paper tutorial video, and this is part 2, meaning we're looking at paper 2. The topic, transport in animals. Without wasting much of your time, let us begin. So I've got two questions for this video, two questions, and I believe these questions will be helpful. Alright, so this is question 1. Figure 3.1 shows a section through the heart. Figure 3.1 shows a section through the heart. So this is the heart that we have. So the heart has got two sides. Okay, it has got two sides. This side is the right side. This side is the left side. So I want you to pay attention. Don't forget that. It is opposite to you. Okay, so your left side is the right side for the heart. Then your right side is the left side of the heart. And as we can see, we've got parts. And these parts are G, H, I, J, K. Okay. So H, G, I, J, these are blood vessels. Then we've got K, which is a valve. These are valves. So yeah. Identify two blood vessels labeled G and I. So we've got this blood vessel here and this blood vessel here. So what is blood vessel labeled G? What is this blood vessel? Pause the video, try to answer that question, then you can play it. Alright, I'm sure you've done that. So this blood vessel here is the vena cava. Okay, the vena cava. It's a vein. This blood vessel is the vena cava, and it is a vein. What veins do is they transport blood towards the heart. They carry blood, taking it to the heart. That's what veins do. So the one which is found on the right side, it is known as the vena cava. And the function of this blood vessel is that it transports deoxygenated blood from all parts of the body, taking it where? To the heart. So as you can see, there's an inflow of blood. Blood is entering the heart according to this direction here. Blood is entering the heart, and it is entering the heart through the blood vessel known as the vena cava. So G is the vena cava, and then I is the aorta. I is the aorta, and the aorta is an artery. What arteries do is that they transport blood away from the heart. So they simply carry blood away. They take it out of the heart. So I is the what? The aorta. The function is it transports oxygenated blood from the heart, taking it to all parts of the body. So we've identified this blood vessel here and this blood vessel. This is the vena cava, this is the vena cava, and this is the aorta. Alright, let's look at B. Which of the labeled blood vessels carry oxygenated blood back to the heart? Which of the labeled blood vessels carry oxygenated blood back to the heart? So oxygenated blood is blood that contains oxygen. If we say deoxygenated blood, that simply means blood that does not contain oxygen. Alright, so looking at what we have here, this blood vessel, as I said, it transports deoxygenated blood from all parts of the body, taking it where? To the heart. So it brings deoxygenated blood to the heart. This deoxygenated blood will then come out of the heart through this other blood vessel labeled H, and then it will go to the lungs. From the lungs, it will now be oxygenated. So once blood passes through the lungs, it will absorb oxygen from the lungs, therefore it will be oxygenated. Then it will come back to the heart through this blood vessel labeled J. So looking at the question, they are saying which of the labeled blood vessels carry oxygenated blood back to the heart? So our answer is J. Okay, J is a blood vessel which carries oxygenated blood back to the heart. Alright, so yeah, identify valve K. Identify valve K. So if you look at this diagram, blood is coming in, right? entering this chamber, at the exit of every chamber there are valves. Okay, there are valves. So as you can see, these are the valves here, these are the valves, and this is a chamber. So as blood is entering, these valves will be closed. Once this chamber is full of blood, these valves are going to open, allowing the blood to pass. Then they will close again, waiting for the other collection of blood. And then blood will now be in this chamber, okay, which is the ventricle, left ventricle to be specific, and then it will pass through this valve, these two valves. Now the question is, what are these valves? So these valves are the semilunar valves. They are the semilunar valves. Okay, they are the semilunar valves. But if you want to be specific, they are the aortic semilunar valves because they are close to the aorta, okay, which is I, the one which transports oxygenated blood to all parts of the body, like we said. Yeah, so K is the aortic semilunar valve. The one which is on the right side, it is the pulmonary semilunar valve. Otherwise, together they are collectively called semilunar valves. So K are the aortic semilunar valves. So we have identified, because they said identify, so we have identified. Now let's state the function. The function of a valve is simply to prevent the backflow of blood. That's what they do. Valves prevent the backflow of blood. They ensure that blood is flowing in one direction only. So they prevent the backflow of blood. Simple as that. Alright. Then let's look at D. Describe the movement of blood from the time it enters the heart at J until it exists at, or until it exits. Yes, that's how it was supposed to be there. Not exist, no, but exits. Yeah, or exit. Describe the movement of blood from the time it enters the heart at J and it exits. And as it exits at I. Vizungu. So they are asking us to describe the movement. How is blood moving from the time it enters at J and then from the time it comes out of the heart at I? That's what they are asking us here. So here's how you describe. Okay, description is simply painting a picture using words. So oxygenated blood, I want you to pay attention. Oxygenated blood, let me try to do some drawings. So let me try to do some drawings. These are the lungs connecting there. Okay, let me connecting there. Then don't mind me, I'm using a mouse, so it's kind of tricky. Okay, then for this one, let me do this. So yeah, let me use black. Okay, so no, this didn't look well there. Let me erase. Okay, let me try again. So move like that. Then let's say this is the body. Then it will be like that. So what I'm drawing, these lines are blood vessels. Okay, so at least I just want you to get an idea. Okay, I want you to get an idea. These are not perfect drawings, but I just want you to get an idea. So this here is the body. These are lungs. All right, so what are we trying to do? Trying to describe the movement of blood from the time it enters the heart at J and then until the time it comes out at I. So these are the lungs. This is where blood is oxygenated. When you breathe in right now, as you are watching this video, you're breathing. Okay, and breathing is the movement of air in and out. So when you breathe in, that's inspiration. When you breathe out, that's expiration. Together, breathing. That's one breath. So one breath, right? So as you're breathing, air is going where? Kuma lungs. That's where it's going. The lungs have got close association with the transport system. Okay, that's what makes it possible for blood to be absorbed by for oxygen to be absorbed by blood. So as blood is flowing, it is deoxygenated at this point. So it's flowing, going where? To the lungs. At this point, it is deoxygenated. Once it passes through the lungs, it will collect the oxygen. And as it is coming back from the lungs, going to the heart, it is now oxygenated. So oxygenated blood, I'm now describing. Oxygenated blood flows from the lungs going to the heart through a blood vessel known as the pulmonary vein. And then, as blood is entering the left atrium, I will pause and then I'll repeat again. As blood is entering the left atrium, these valves will close. They will do what? They will close. What are they going to do? They will close. So as blood is entering the left atria, or left atrium, sorry, the left atrium for singular, what will happen to these valves? They are going to close. Once the chamber is full, the walls are going to contract. And that's what we call what? Atriosystole. Once the chamber, and what is happening on the left side is also happening on the right side. But our focus here is on the left side because the question is saying describe the movement of blood from the time it enters at J up to the time it comes out at I. So our focus is on this side and not on this side. But bear in mind that what is happening on this side is also happening on this side. So blood is entering at the same time. These valves, they are closing and opening at the same time. Blood is coming out at the same time, but it's just going to different destinations. So what is happening on this side is equally happening on the other side. Okay, cool. So when this chamber is full, what does that mean? It also means that this other chamber is also full. All right, so oxygenated blood will flow from the lungs going to the heart through the pulmonary vein, and then the left atrium will start receiving blood. Once the left atrium is full of blood, but before it's even full, as it is receiving, these valves are closed. Once it is full, these valves will open and there will be an event that is going to take place, and that event is atriosystole. Systole simply means to contract. Atriosystole. So atriosystole is the contraction of the walls of the atria, these chambers, the walls of the atria. When they contract, that is what we call atriosystole. So when they contract, what are they going to do? They will push that blood. It will move from this chamber to the other chamber. So if you pay attention to your heartbeat, it's actually twice. It's tutu, 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 not tutu, tutu, tutu. No, it's tutu. So the first, it's at this point when these chambers contract, which is known as atriosystole. So atriosystole, after atriosystole, blood will flow going into the what? Left ventricle. Again, as these ventricles are receiving blood from this chamber, these valves are going to close. They will close. Once the chamber is full, what does that mean? It means when this chamber is full, it means this chamber is empty. So these valves will close and this chamber will start receiving another set of blood. So when this valve closes, these valves are going to do what? They are going to open. So once this chamber is full, these valves will close, then these valves will open. And then another event will occur, which is ventricular systole, the contraction of the walls of the ventricles. So blood will be pumped out now, out through this blood vessel known as the aorta. Hope I've made myself clear. The question actually carried 5 marks, so I had to put some effort there. Otherwise, those are the events. Those are the events. Let me erase this. All right, let us move on to question 2. Interesting. Question 2. Figure 4.2, okay, this is 4.2, shows sections of blood vessels R and S. So this is a section of blood vessel. This is blood vessel R, and this is blood vessel S. Name the type of blood vessels shown in figure 4.2. What type of blood vessel is this? What type of blood vessel is this? So looking at the structure, you are able to tell, to say, okay, this is a blood vessel which is known as that, and this is the blood vessel which is known as that. Looking at the structure, you can tell which blood vessel is which. Okay, so when you look at this, we can see that there is thickness of walls of the wall. The wall is thick, okay, and then this one, the wall is thin. So comparing the two, this has got thick walls compared to this one. All right, so let's identify what is this blood vessel. So this blood vessel here is known as the artery, and this blood vessel is the vein. So blood vessel R, artery; blood vessel S, vein. Are we clear? Hope we are clear on that one. And then describe, so name the type of blood vessels shown in, okay. Describe structural differences between the blood vessels R and S. What's the structural difference? I think I've already mentioned it. Okay, this one, it has got thick walls. This one has got thin walls. So blood vessel R has got thick walls, while blood vessel S has got thin walls. Another one is blood vessel R transports blood away from the heart, taking it to away from the heart, yeah. And then blood vessel S transports blood towards the heart, because we've identified blood vessel R to be the artery, then S to be the vein. So those are the characteristics. So blood vessel R. But now looking at the question, they're asking about the structural difference. So it's okay to say blood vessel R has got thick walls, while blood vessel S has got thin walls. Okay, we can also add to say blood vessel R has got a narrow lumen. So lumen is the space. Then this space in the middle, that's the lumen. So blood vessel R has got narrow lumen, while blood vessel S has got wide lumen. All right, 2 marks, nothing much to give there. Define a blood vessel. 1 mark. Define a blood vessel. A blood vessel is simply a tube that transports blood around the body. You can also say it carries. Actually, it carries. It's a tube that carries blood around the body. That's what a blood vessel is. All right, my excellent biology students, look for more questions. I'll give you more questions. I'm sure the assignments saved you better. I hope this video was helpful. And yeah, this has been Mr. Philip Kawama, the excellent biology tutor. Looking forward to the next topic as we conclude on this topic. Stay blessed.